Hello everyone, welcome to my video. In this video, we are going to dive into a very specific question. Does the HiPPO model improve STM-based language modeling? The HiPPO model is an interesting approach to sequential data processing. It provides a unique way of integrating memory into models like RNNs, promising better handling of long-term dependencies. But despite its theoretical advantages, we don't have much empirical evidence about its performance when applied to language modeling tasks. I decided to explore this by myself because while the paper presents a lot of mathematical theory, it doesn't offer any results on language modeling. So I thought, why not test it out on STM and see if it helps improve performance? The STM is a widely used neural network architecture for sequence data. It's famous for mitigating issues like for vanishing gradients, making it effective for tasks like language modeling. But could adding the HiPPO model bring any noticeable improvements? That's what I aim to find out. Now that you have an overview of the goal of the experiment, let's dive into the setup. I'll walk you through the model architecture, the key components I used, and the hyperparameters that drove the training process. We start with the custom LSTM, which is built to integrate the HiPPO model. The key components here are the HiPPO state update and scaling factor computer classes. The HiPPO state update class is responsible for updating the HiPPO state at each time step. The HiPPO state is updated using a combination of the scaled HiPPO matrices and the new input state. The scaled matrices A and B control how much of the previous HiPPO state and the new input state influence the update. The scaling factor compute class applies scaling factors to matrices A and B at each time step. Inside the custom STM, we use the HiPPO state to modulate the STM's memory update. After processing the input at each time step, the STM updates its hidden state, and the HiPPO state is adjusted using the HiPPO state update class, which then influences the memory state for the next time step. For this experiment, I used an embedding size of 128, a hidden size of 1024, and 3 STM layers. The HiPPO model was set with a dimension of 32. This choice was made because the HiPPO model provides an inductive bias that can be helpful in certain tasks. It doesn't seem to play a significant role in language modeling intuitively. Additionally, setting the dimension to 32 allows for faster training. Due to budget constraints, I was only able to train both models for one epoch, using a learning rate of 0.001 and a batch size of 64. However, one epoch is sufficient for comparing slightly different models on a large dataset like Wikitext 103, and the dataset is so large that even a single pass provides enough information for initial comparison. To prevent overfitting, I apply a dropout rate of 0.3. The optimizer used was AdamW with a weight decay of 0.01, and I clipped the gradients with norm of 0.25. I chose the Wikitext 103 dataset for this task, which is a large collection of English Wikipedia texts commonly used for language modeling. Now that everything is set up, we are ready to compare the performance of the two models, one using the standard STM and the other with HiPPO integration. I'll now walk you through the results of this experiment and see how HiPPO model performs. Here are the perplexity scores for both models. For the STM model, we get a validation perplexity of 3.92 and a test perplexity of 3.90. For the STM with HiPPO integration, the validation perplexity is 3.97 and the test perplexity is 3.94. As you can see, while the STM model has a slightly lower perplexity, the STM with HiPPO integration actually shows a slightly increase in perplexity, The validation perplexity rises from 3.92 to 3.97, and the test perplexity goes from 3.90 to 3.94. This is an interesting result. You might expect that adding HiPPO will help improve performance, or at least not hurt it. But here we see that despite the added complexity, the HiPPO integration slightly increased the perplexity. It seems that while HiPPO provides a mechanism to better manage long-term memory, it didn't lead to better generalization in this case. One possible reason is that HiPPO is not used for inductive bias for language modeling. Overall, while the HiPPO integration didn't improve performance in this experiment, it's important to note that it has successors like S4 and Member, which have shown strong results in language modeling. That's it for this video. Some kind of boring, right? Thanks for watching.